I want to talk about JavaScript today, and especially more about the new version of JavaScript, the current version of JavaScript called ES6, because I've been a JavaScript fiend for a long, long time. I've written a few books on it, and I always liked the language, and people always look at me like, what's wrong with you? But I'm used to that question for a long time already. And the bigger problem that I find is that we innovate JavaScript too fast that we implement it right now, and we innovate it into spaces where it becomes very shielded from the rest of it. So there's lots of forking going on of JavaScript environments, and I remember when it was pretty easy to just open a text editor and write some JavaScript, and nowadays, like, go to the command line, type in these 12 commands, look at 40 screens of scrolling stuff and hope there's no error in there, and then you can write your first JavaScript. And I'm like, what's happening here? What's going on? So I'm Chris Harmon, I'm Code Poet on Twitter, so if you don't have enough pictures of hedgehogs and kittens in your life, that's where you get them from. Let's talk JavaScript. Old issues, learning process, tooling issue, library framework issue, ES6 and the promises of ES6, and not promises in JavaScript, but the promise of ES6 as a language, ES6 and its realities, and TypeScript, and then I talk about the ChakraCore thing at the end of it. None of this is a sales pitch, all of this is open source, use whatever that makes you happy, and I'm really not that worried about that kind of stuff. But I love JavaScript and I love the web. To me, the web is like the platform number one. I used to be a radio journalist. That's how I started my career. And then I learned about the internet, and I'm like, okay, this is cool. I can publish worldwide without committing a crime or without paying a lot of money. That's pretty awesome. So let's do that. And that's why I supported the internet from the very beginning. And JavaScript on the client side is what gave us the fidelity that we didn't have before in just HTML and CSS, because CSS later on got animations and transitions and these kind of things, but in the beginning it was just fonts and colors, and you had to do everything that was movie and jazzy, you had to do in JavaScript, form validation and these kind of things. JavaScript client side is issues though. The first is that it's not fault tolerant. CSS and HTML are both built to be fault tolerant. This means if you do something wrong, the browser says, okay, I'm trying to fix it for you and I'm still showing something. We had to do that because we're bad as developers and we put terrible code on the web, and when the browser doesn't show it, people blame the browser and not the developer because the developer is unknown. So HTML, you say an element that it doesn't know, it just tries to render the element content. If you don't close a p tag, it closes the p tag for you. In CSS as well, if there's a line that it doesn't understand, it just goes and goes on with the next line. In JavaScript, it goes like, oh my God, God has forsaken us, we have to now go and have a meeting, and it doesn't do anything any longer, and the whole thing is broken. There's many different parties that mess with it. There's front-end developers, there's Java developers who hate it because it stole their language name. There's people who basically copy and paste things from jQuery and put it in there and use 12 different libraries. Anybody's invited to use JavaScript, but nobody takes it serious. You don't know the environment it runs in, and when you tell people my so-and-so needs this and that browser, you released a prototype. You didn't release a product. Because you cannot tell people what browser to use, because a lot of them are not allowed to change to other browsers, or a lot of them don't even know what a browser is. I remember when I was, I still do it, when I get to old Windows machines and people use Internet Explorer 6, 7, and 8, I just install the newest Firefox on that machine and link the Internet Explorer icon to Firefox. Because all they know is clicking on the icon, they don't know what a browser is, and it's like, oh, that looks different from, yeah, that's new version, it's really much better. And it's always been a part of the browser, and dependent on its release and upgrade cycle. So all the cool stuff in JavaScript is always in the newest browsers, but if you're with an old browser, then you cannot get it, and that was a terrible idea. Hardwiring the operating system with the browser is still a very, very bad idea. That's why we got all these outdated Android devices as well, and of course Windows XP and blah. The JavaScript, the language, has its other issues and opportunities, and it's quite funny when you say, for example, that the type of not a number is number, and that's true. There's no type safety, there's no classes, and it feels rushed. If you come from a higher language, then JavaScript feels like this thing that somebody randomly put together in 10 days, and that's exactly what it is. Because it was done in 10 days, because it had to get out of the door, and we needed a client-side language that was not Java. And then he called it JavaScript, which is confusing as well, because it's Java to JavaScript is ham to hamster. You can do it, but don't kind of thing. It's just a very weird language. But that's why I loved it. The problem, of course, is if you make a language this flexible, like no classes, no type safety, then JavaScript is hungry. So the engine needs to do a lot of stuff for you and needs to do the things all the time. So you don't know when you declare a variable how much memory that variable will need. In other languages you say it's an integer, it's a string, it's a long and whatever. In JavaScript everything is everything. And that's of course a problem for the Internet of Things. Because there you will have memory problems, there you will have problems with the processors, and you don't want to have a language that just says like, you know what, I give you all the memory you ever want, and it's your job to find out where I leaked memory because I don't give you any tooling for it either. So the JavaScript learning process is something that I've been blaming on the issues that we have with JavaScript a lot as well. Because the JavaScript learning process has always been interesting. You use view source and see what others are doing. This is what we did in the past. So it's how we learned JavaScript before we wrote our first books and pretended before we actually knew something. We copy and paste the bits that look like they're responsible for some things. We change some numbers around and run into errors, and we blame Internet Explorer. And this is how I learned JavaScript back then. Of course, we evolved past that a bit. Nowadays it looks different. We search for a solution on Stack Overflow. We copy and paste the bits that look like they're responsible for some things. We change some numbers around. We run into errors. We blame JavaScript for being a terrible and badly designed language. And we also, for good measure, blame Internet Explorer. I call that the full Stack Overflow developer. And it's quite rampant. There's actually getting books out there. And I loved that the other day where somebody said the only error handler you ever need, try something, catch E, and then location href, Stack Overflow, search for this. Of course, once you do that, somebody will rewrite it in ES6 and make it shorter. Yeah, you can use an arrow function there and make it much more readable, because obviously it's not a good idea. Anyways, with ES6 we now have a clean new slate. So forget about all these old JavaScript tools. Don't buy my book any longer. It's really outdated and you probably don't get it anymore. I'm writing a new one, I think, soon if I find the time. But look for ES6, don't look for JavaScript, because we have a new starting point here, and we looked at the language itself and we made it much more what we need nowadays than this construct that was basically randomly put together for a short, long time. Babel.js is a great website to actually not only transpile ES6 into JavaScript so it runs in all the browsers, but it actually has a massive documentation about all the things that you need to know about ES5 and ES 2015, ES 2016, ES7, ES next, whatever we're going to call it next. It also has a repo in there, so you can type the new version and see what under the hood Babel just generates for you, so what the browser will see in the end. So it's a very, very good way to get started with ES6. There's also a great series of posts by Nicolas Peraka at ponyfoo.com. There's 350 bullet points about different things on ES6, and there's a great book which is free to read online and costs $20 if you want to buy it, by Axel Rauschmeier, and I'm one of the editors on that one, which is not only explaining what the language is, but also the decisions, like why something in the language is the way it is. And there's weird stuff in there. For example, we have array contains. Originally we had in something else as well, and we couldn't make it anymore because an older version of MooTools, the JavaScript library, had that in there. So putting them into the standard of the language would break thousands of websites that people don't maintain any longer. So that's the kind of mess we got ourselves into with JavaScript already. Then, because we have the tooling issue, JavaScript tooling feels rudimentary. For me, it was always just coming from a text editor environment where I had alert as my only debugging tool. I'm amazed what browsers have these days. The in-browser development tools are incredible, especially Chrome and Firefox are doing an incredibly good job in that. We're getting there, and we're putting more effort into it right now as well. But we also realized that on Windows, and Internet Explorer and Microsoft Edge developers, they don't really use the developer tools because they already use Visual Studio. They're already in an environment where they actually want to debug in the editor rather than running it in the browser and debugging in the browser. And that's something that never occurred to me because I don't use Visual Studio, and I used it last week for the first time, and I'm like, oh, that's lots of buttons, excellent. But seeing that my application is running and showing me the memory it's using and showing me all the problems that I have that I had to fiddle around in the browser with was quite good. The other problem is, of course, that the developer environment differs from browser to browser. And as a as a 9-to-5 developer who's just happy with the IDE, I don't want to learn about all the developer tools, and I don't want to test. It's bad enough that I have to test in different browsers, but I don't want to do my development in them as well. The library framework issue is a big one as well. JavaScript abuse is absolutely rampant. This is the nasa.gov website, and after like 2 seconds of loading, it gives you an impression what space is like, the vastness and the beauty of it. Until after like 14 seconds it starts showing you the first content, and then it shows you a spinner that something is loading, and then it shows you the content. And this is because, I think they fixed it by now, this was because they had jQuery and Ember in one JavaScript file in the head of the document. And every performance talk of the last 7 years told you not to do that. But why is that done? Not because the developers are terrible, because there was a press release and the website had to be done in that afternoon. People were drunk, things happen. You know, it's as we do. We just press buttons and things have to go out. But the problem with it is that people just don't remove old libraries anymore. The MooTools issue that I said before is one of them, and that was a friend of mine in England. I love that quote. A simple way to detect how old a part of our massive site is checking which version of jQuery was used in that part of it. It's like rings in a tree trunk. They had like over 170,000 pages maintained by 50 different departments in a large organization. And it basically, his job was to re-evaluate and do the whole new website. And he's like, I have no idea what's going on here. So he just wrote a grep and found old versions of jQuery and know how long these parts of the page have not been maintained anymore. And that's just sad that we just rely on these things and think they're magical pixie dust and we don't have to worry about it. Paul Lewis gave a great talk at Full Frontal last year, or like a few months ago, about libraries and comparing them with each other. And one of the findings that I found really interesting was that people always say the DOM is slow. And the DOM, accessing the DOM is a terrible thing. That's why we do it in every line of jQuery that we write. And he did this testing where he created an image gallery. And he created 100 images, 200 images, 300, 400, and so on and so forth. And measured how long it takes actually in milliseconds for the page to render to show the first thing. And he found out that the blue stuff here is JavaScript executing, and the red stuff is the DOM. So when you use something like React or any other library that uses a virtual DOM, it becomes more and more computation active in the library, and it takes longer for the thing to load. Whereas if you write vanilla JavaScript where you use the DOM, the browser starts optimizing for you. So this is Chrome. So the more you actually add it, the faster it became. That's because it's caching the things that haven't been changing. And most virtual DOM libraries don't do caching internally yet. They just create a new DOM every single time and then flush it out into the main DOM. So we try to be too clever and not allow the browser to do the clever things that browsers do for us, which is a lot of things. And he found out, like, in different libraries and how long they take to render till the first second on an N5 and on an iPhone, it can take up to 2 seconds for the page to show up. And in general, when you look on your phone and something doesn't happen for a second, you already think that that's the end of the world and something's broken, and you go back to the shop and shout at them and get a new phone. Frameworks are great. They're fun to use. You achieve a lot very quickly. Like, oh my God, we have another client that needs a to-do list app. No, none of them do. But everybody has a to-do list app as the out-of-the-box demo. You build complex apps in a matter of minutes, they work around pesky browser bugs, and they're good for your CV. So putting React on your CV right now, best thing ever if you want to have lots of calls and you're a lonely person. They also come with developer costs because you have to learn a new framework when it comes out. You also have to learn the next version of the framework because not all of them are compatible with the last version of them. So that's, again, as I said in my keynote earlier, open source and free stuff also means overhead and spending time and money on it. Debugging frameworks is a problem as well. Sometimes you run into problems that's the framework problem, so you have to start debugging the framework, filing bugs, fixing it for them, pull requests, getting called out that you put a semicolon in the wrong space, and then basically giving up and going to the bar. Setting up developer environments, everybody has to start like installing 10,000 things. You need that editor for it, you need this kind of version of terminal for it. And cutting down on possible hires, adding to the onboarding time, because once you're married to a net framework or a library, you cannot hire other developers anymore. You have to expect them to come in. And strangely enough, all of us have our pet libraries that we love, and we come in, and we basically say, I'm not working with that one, let's rewrite it in the other library. And we do that more and more. It's just frustrating. We should consider the effects we have on our end users. The time to load and execute on the machine, on the unknown machine that might be an old, outdated phone with no memory anymore in it and these kind of things, is the most important bit. So buy yourself a shitty hardware. Buy really, really bad Android phones, buy really, really bad Windows phones, buy really, really older iPhones, test on those things, because if the things perform nice on those, they will perform on the good ones as well. With these things, we're so far removed from our end users, we test the wrong environments. Everything looks beautiful here, and it works for me. Why are our clients complaining? Because they use other computers. CPU usage, bandwidth, frame rate, memory usage, battery hunger, these are all important things. The next users will be on mobile. And there's no way around that. Africa, India, Bangladesh, all these emerging markets, the markets with users that want new stuff, will be on mobile and not on desktop machines. So think about that first and foremost. And also think about poor people like me who are rich as hell, but then go on roaming costs and pay like £6 per megabyte on my roaming SIM card here, which means loading the average website costs me the same as a cinema ticket. So hopefully your website is as good as Deadpool was. Otherwise, I'd be very pissed. So we're going full speed on innovation. We do things like componentized web, extensible map manifesto, WebGL, WebAssembly, ASM.js, PostCSS, progressive apps. These are all amazing things. These are all things that the web should be thinking about and should be going towards. Progressive apps is quite amazing what you can do with those, and Alex Russell just gave a really good keynote at Fluent 2 days ago in San Francisco about it. And WebAssembly, we just announced that we're using that in Microsoft Edge in a new build, and Chrome has it and Firefox has it, so that is binary code for the web. It's pretty amazing what we can do with those things. But the problem is that instead of waiting for these to happen, we write libraries to patch and to simulate. And simulation is always slower, no matter what you try. So we work around browser issues in our libraries. We make web standards of tomorrow work today. We build solutions to clean up other and make them smaller. And each of those comes with a don't use in production. That was my fascinating thing when you see like this massive library, 10 times smaller than jQuery, much, much faster. Here's documentation, don't use in production. So what do I use it for? Slide decks? What do we do? Do we impress each other, or do we want to build software here? This is quite scary how winning Hacker News for a day became more important than releasing things for the bank that everybody has to use every day and is super annoyed by their interfaces. Now, ES6 and its promises. JavaScript evolves. It evolves in a weird way and slowly, but it evolves. So we had 1997, we had ECMAScript 1, then 2, then 3, then things happened and people got confused, and I think the Transformers movies came out and something went wrong. And we had Flash and we had Silverlight and JavaScript 2005, 2007, basically people like, don't look at that. And then in 2009 we had ECMAScript 5, and now in 2015, 1 year later, we got ECMAScript 6 signed off. It's a standard now. It's not a moving thing any longer. Here is a standard that you can work against, that you can tool against, that every JavaScript engine, no matter if it runs client-side or server-side, can implement and does implement. A lot of people are very concerned that we now have ChakraCore for Node, because it was so much easier to only work with V8. Monopoly is bad, no matter where it is. And when it comes to the browser differences between browsers, it's mostly in the rendering and the CSS. The JavaScript support is very, very good in all browsers. Even in iOS 9, we have a proper support for ES6 where it lags behind a lot of other things like CSS. So we have ES6 now. It's 5 years since the ratification. It's significant changes, 15 years. It's backwards compatible because we can't break the web. It's ratified, and it has so much goodness, it technically has to be fattening. So there's so many things in there that when you read through it, like, oh cool, this is, I want this, I want this, I want this. But in essence, it's for different people. As I said before, JavaScript is touched by many, many people. Anyways, we have syntactic sugar that makes it easier for us to write things. Why we use jQuery really? Because nobody wanted to write document get element by ID, because that's much longer than a $sign. Unless the dollar means whatever, you don't know. Then scalable applications where we have things like classes, promises, iterators, generators, typed arrays, which is actually a fallout from WebGL, funnily enough, and modules, and that's a very important part because we want to have proper module loading, and we gave up on a lot of web component standards for the sake of ES6 components and modules because they seem to be much easier to implement. And for library builders, we got map, set, and weak map, proxies, symbols. So all the libraries became much faster now as well, now that we can use ES6 functionality in them rather than ES5. The support is encouraging. There is a great, by Kangex, there's a compatibility table where you can see all the things that are green and red, and which means what supports what, and that includes desktop browsers, mobile browsers, runtimes, and so on and so forth, editors. In reality, though, we have still a problem that there is a backwards compatibility issue, because some of the things in ES6, like arrow functions in older browsers, are just syntax errors. And as I said before, JavaScript not being fault tolerant, it just doesn't say like, oh, I don't know that line, that's fine. It just says like, I'm not going to play with you any longer. Which is a problem if you have users on older browsers. But, and this is a thing I've been talking for years and years. If you have users on Internet Explorer 6, don't confuse them with beautiful interfaces. They're not used to that. They just want the gray boxes and 12 checkboxes and drop-down boxes. Animations basically makes them wonder what's going on. There was a decision in upper management to hate your engineer, to hate your people working for you and keep the software insecure. That's why they still have to use Internet Explorer 6. Give it HTML, give it CSS, give it a bit of JavaScript after you put an if statement around everything that you use, and you will be fine. And then you don't have to worry about these anymore, and you can concentrate on the evergreen browsers that we have today. Don't block out Internet Explorer 6, 7, 8, 9, 10. Don't block them out, but give them only things that work. And when you build on something that works and you make it better afterwards, then you build a much, much better tool because you can never go wrong. It's like an escalator. Escalators are great because when they break down, they're stairs. You know, it's a bit more effort, but you can still get to the other floor. Whereas a lift that breaks down is just a small room where you awkwardly stand around other people that you don't want to be in. So build your software like escalators and you will be fine. Solution, of course, right now also is if you want to get this code out to everybody is transpiling it. Babel.js I talked about before converts ES6 to older versions of JavaScript on the server or the client. Please do it on the server because on the client you never know how much memory the thing has. It's used by Facebook and many others, and it's used in editors and tool chains. So transpiled code, funnily enough, looks a bit odd at times because it's just optimized to run and not to look. I love this tweet the other day where somebody like reading this JavaScript code that ends with this, and Perl has a punctuation reputation, and that's Webpack generating code. That's the end of a Webpack thing. So this was never meant for human eyes. You know, this was like COBOL and these things. These were meant for computers to talk to computers. There's a transpilation toolchain, nice. So these are all the different ways that you can transpile JavaScript into ECMAScript into JavaScript, and that one shows you how much gzip it has in size, how much it likes to compile and execute, and the runtime, and so on and so forth. So there's a cost involved with transpiling, of course, as well. The problem is it's an extra step between the code that runs in the browser and the code that you write, so you're not debugging the thing that actually ends up in the browser. So that can be a real problem when out of a sudden the thing is slow and you're like, but my code is so optimized, what's going on here? Because some magic comes out on the other side. We hope the transpiler creates efficient code, which they do, and Babel has a lot of contributors, so I've got no worries with that. We create a lot of code as well. Generated code in general is bigger than handwritten code because you basically just don't know how to optimize it. And browsers that support ES6 will never get any code. That's the real problem. So when people complain about the performance of ES6, we cannot even test against it because nobody uses ES6 yet. You see what the problem is? It's like this chicken and egg issue that we have. One issue around that is TypeScript. TypeScript is an open source language that has all the features that Java developers always wanted to have from JavaScript: classes, proper type safety, tooling support in Visual Studio and in Eclipse and all the other big ones out there. And it's in use right now by Microsoft heavily, and also Angular 2 is written in it, Dojo is written in it, the Visual Studio editor is written in it, Outlook 365 is written in it, so all the stuff that we have in JavaScript on the web uses TypeScript because we didn't want to re-educate all of our Java and C# and C++ developers to write JavaScript, so we gave them a type safety and a class-based language instead. It works in the browser and it creates JavaScript at the end of it, so there's no extra environment that you have to install. It's class-based, type-safe, editor tooling support, used to write large frameworks and used heavily in Microsoft. Now, the last bit that I'm going to cover is the ChakraCore thing. ChakraCore is a lighter version of the JavaScript engine inside Microsoft Edge, which is Chakra. It's just the core of Chakra. That's why the name is clever. Okay, it isn't. We basically got rid of the DOM levels and the things talking to the operating system, and we just gave you the engine itself. The architecture of Chakra is incredibly intelligent, and I don't understand half of it. But there's great talks about this where in detail they're getting really, really excited about what they've done. What I found really interesting is that we got a simple JIT and not a full JIT to actually do a lot of just-in-time compilation before we go through the whole script. And we have multi-threaded JITs as well, rather than having just only one thread for JavaScript to run. So heavy JavaScript gets split up into several workers rather than like several threads, rather than just one thread. And that gave us a lot better performance compared to the older JavaScript engines that we had. In the ChakraCore thing, what we also have is a limit on JITs, so you can basically turn them off completely in case you want to run it on an IoT device, or you can say only use so much memory for just-in-time compilation, the rest just do with a normal compilation. So right now we got them running on Raspberry Pi 3s, runs Windows 10, and that's pretty awesome because you can carry the thing with you and like, look what I have, a computer. Speed comparisons are always pretty annoying because everybody has a different speed test engine and things. So I grade them out here when we compare them to Chrome and Firefox because I don't care. What I really want to be faster is faster than IE11 because that thing has to die. And it's still in Windows 10 because people rely on Internet Explorer only technology, and we cannot just break the internet, and we want to book flights and do my expenses, which need these kind of functionality as well. But I'm not bitter about this, I just want to point it out. So we're now, what is it, like 10% faster than Google, but that doesn't really matter because we're about 50% faster than IE11. And that is really good because speed is important in JavaScript because, as I said before, we're overusing JavaScript. And Octane is an Apple one, Jetstream is a Google one, I think. There's 10,000 of those, and every month a new browser wins, and we all pat each other's back and say, like, that was amazing. In essence, we want them to be faster in all of them. So it's good there's competition, but don't be a fanboy of one browser. Surprises happen. Node.js, for example, me being on this very open source, fruit-based hardware here, I thought everybody has that to run Node. But 42% of Node.js users are in Windows. That's more than any Unix together. And that was really surprising for me, and it also showed me that there is an interesting community that we should support more with what we're doing in JavaScript in Microsoft. And that's why we did the ChakraCore engine and made that Node compatible. So now you can actually run it on Windows 10, sadly enough so far, but I've been told really soon Linux is ready as well, and OS X will be the next one, where you can run Node with Chakra instead of V8. And a lot of people had compatibility issues with that and were very annoyed about this, but we put a compatibility layer in there as well, where we simulate things that V8 does that ChakraCore doesn't do. So your V8 code will not break, although you're using the faster and better engine, which is something that we wanted to make sure that we don't pull the rug out from people that wrote only for one engine, although technically we should, because you should not write for only one engine. Again, this is good for the Internet of Things. And it also means that with the just-in-time compilation that we have in multiple threads, we also have a different way of debugging right now, and that's time travel debugging. I cannot demo it here, but it's pretty amazing because originally in Node what we had is console log, and this is not fun for asynchronous code. If you do asynchronous programming, you just don't want to log because you don't know which order your logs come unless you create a log of your logs, which is where craziness ends. And with time travel debugging, you cannot just only go forward in your points, in your breakpoints, but you also can go backwards. So it keeps the whole state of the JavaScript engine in the debugger as well. So all your objects and how the JavaScript engine manipulated them, you get snapshots of that. You can forward and backward in your debugging, which was before that not possible with any other engine. So that's coming into Visual Studio, and that's coming into our developer tools as well. There's a great video on that on YouTube. As I said, there was a compatibility issue with V8, so we got that Chakra Shim and ChakraCore. Chakra Shim is where we use all these compatibility modes that Node already had for V8, and that means your Node-based V8 code is now running on Chakra as well, so you don't need to worry about that. You should though, you should clean it up, because in essence, sooner or later there will be maybe another JavaScript engine, or you don't want to get stuck with the like, oh, I need to use an outdated engine because my code doesn't support the new one. This is not a good idea, which companies have been prone to do, to change their engines around and leave you in the lurch. A very interesting part about this was as well that people are very afraid of it. They're like, oh, we had such a wonderful environment where we had one engine, now we got two engines. This is called open. This is called opportunity. And I think if we had only one browser on the web would look terrible. If Internet Explorer 6 were the only browser we still had, if Mozilla hadn't happened, then we would have a terrible, terrible internet. And I think JavaScript on the server side, which is the growing thing and will be the new thing and is the new thing, needs to have more opportunities as well. Interestingly enough, when we had the ChakraCore mainline, we brought it into the mainline of Node. So we did a pull request of Node and said like, hey, here's our ChakraCore version. Do you want to try that out as well? You now can run a binary in the interim. So you can run a binary of Node.js, which has Chakra and in parallel to your other one. So what you're doing right now with Node doesn't break, but you want to switch it out and try it out, you can do that. So they can run in parallel. But now that the Node Foundation has taken over our fork as well, it just becomes a part of Node. And the performance is like is getting better and better. So the blue one is how Node performed, and the green one was ChakraCore, the yellow one was Chakra. And here is the higher it gets, the better the performance is. You can see that actually when we started creating them and we started testing them more and more, we found a lot of things that we can optimize, and now it's running faster than the out-of-the-box Node did before. The compile times on ChakraCore is how we test things, and as we want to keep it safe, we do it on our own stuff. So the TypeScript compiler, the Visual Studio Code, Team Foundation server, and the Encyclopedia app, all of those became significantly faster than we went to ChakraCode than just with Node.js with V8. So thinking about your application, trying it out with ChakraCore, you will probably see that your compilation gets faster as well. It's on GitHub, it's open source, it can be forked, it can be commented, it can be played with, you can put smileys in the comments, you can put frowny faces in the comments. Please give us feedback, and in summary, JavaScript is now ES6. Forget about looking about JavaScript, don't trust any tutorials that say like, here's how JavaScript works, especially when the date is 2004. People still look at this stuff, W3 schools has to die. JavaScript moved beyond the browser. It's not only a browser web engine kind of thing anymore. Like real applications are written in JavaScript. Server-side farms are maintained in JavaScript. Node.js runs really, really heavy websites. It's a very, very interesting environment to build in. We have a tooling problem because now we have too many options. I've been told for years and years JavaScript has not enough tooling, and now we have too much tooling. I think we have like 10,000 ways to transpile ES6 into ES5 and pack up your things, gulp, grunt, gulp, burp, fart, whatever the things are called, broccoli. There's 10,000 of them every week, and we don't even have time to look through them any longer. Sooner or later there will be one or two winners. I remember when I used to blog for Ajaxian in 2006, we had 137 different Ajax libraries, and in the end jQuery is the only one that people ever used other than Dojo and YUI. And the other day also we had a competition of like static page generators. I love that because HTML is static. You know, you could write an HTML page, but no, we make like Markdown to JavaScript to HTML to create a static page from like Markdown and JavaScript. And I think they found over 125 or something like that, and 70% of them don't work anymore because they break in the latest node. But nobody ever went back to them because they won Hacker News for the day already with their single page application thing, and we're done. JavaScript needs to cater for a lot of different developer needs. So if you're a fat client developer and you go into JavaScript, you're like, holy cow, what's going on there? If you're like me and you started with Perl and you get into JavaScript, then you're like, this is almost as unreadable as my old language. I like that. And I don't worry about it, and I just liked it that I can, on a train, offline, I can write some code rather than having to have a local host running or these kind of things. Help the language by picking what makes you effective and doesn't hurt your users. So don't rely on libraries to do the magic for you. A lot of times you will find that you don't need the fixes for the library anymore if you just don't give the complex JavaScript to Internet Explorer 8. Don't give it to it. Don't just say, don't even tease the people. There's no problem with a button not showing up when there is other functionality there. For example, I just built something for Build, a demo where you can use the camera. And what I do is I do testing on the camera. If a camera is available, then I show you the button Start Camera. If the camera is not available, I give an Upload button. That's all you need. I don't need to confuse the end user with a button that doesn't do anything when I click on it. Just if statements are a very powerful thing. It's called progressive enhancement. It's like jumping into the river after checking if there's any crocodiles in there. Probably a good idea. It's called an if statement in programming, and we can use these kind of things. Help improve the tools that are being built right now. Don't build the next bulb, grunt, gulp things. Fair enough. There's probably some very good ideas that you have that you hate in the other ones. Talk to people. I know it's scary. Like communication, and try to tell like, hey, how about we build this, fork the thing, fix it, say like, and now it's 20% faster, and then it will probably go in the core, much like ChakraCore became part of the Node core without us having to fight for them and have to buy them or something like that. And that's all I have, so thanks very much.